All right, so the final exam, let's make sure we're all clear, which really will just be the 5th exam. You know, it's just chapters 15 and 16, just this new material, not old stuff. It's not comprehensive. Just forget about all that old stuff. It's not on the final. It's only the new stuff. Chapter 15 and 16, it's just the 5th exam. It's just the same weight as all the other 4 exams. And in fact, it's the one people do best on usually. 3 and 4 are the hardest. The ones the one you just took and the one right before it. 3 and 4 are the hardest for students usually. The material is hardest. 5, this is the best. This is your chance. If you're not happy where your grade is, most people's grade go up on the final because this is easier material. Most people get a pretty good grade on this one. So, 5th exam, and it is, when is it? 2 weeks from today. It's Tuesday, December 12th, and then we're done. So 2 weeks from today, this course is over. We'll take the final from for 2 hours, 1 to 3 p.m. On that day, we'll actually meet for 2 hours instead of, we'll probably just go 1 to 2. Anyway, something like that. We'll start at 1. Start at the normal. 1 instead of 1:30. Huh, that's different. Yeah, I should make note of that. Finals week, everything's a little different, so that'll be finals week. We meet at 1, not 1:30. Yes, that's important. Everybody hearing me on that? Not 1:30, 1 o'clock that day. 1 to 3. We'll take the final. Questions on the final? It's just a normal test. Bring your 3x5 card. Get a 3x5 card like normal. Put anything you want, front and back, kind of thing. 5th exam. If you want to know where your grades are, they're all in Math Excel, right? Total overall grade, quizzes, everything's in there. You can figure out right where you're at. All right, let's go ahead with the new stuff. So chapter 15, which we started last time. Find the set of outcomes that occur when we flip 3 coins and obtain more tails than heads. All right, so we're in probability now. We're into like doing random kind of things, rolling dice, flipping coins, drawing cards out of a deck, things like that. All right. What's the chance? What's the chance? Have we talked about this? I can't remember. What's the chance if you flip a coin of getting heads? 50%? 1 out of 2? I agree. You all agree? That's correct, right? Half. You can say it fraction, decimal, or percentage. It's all the same thing, right? The chance of heads is a half, or 50%, or 0.50. It's all 3 different ways to say the same thing, right? So chance of getting heads. What's the chance of getting heads twice in a row? What if I'm going to take a coin, flip it, get a heads, flip it again, get a heads? What's the chance of getting heads twice in a row?
Like 25.
Is it 25?
I think so.
25? You agree with that?
Just a guess.
Think so? Johnny agrees. How do you know?
2 out of 4.
2 out of 4? So what would 2 out of 4 be?
Could be 1 out of 4.
Was it 1 out of 4, not 2 out of 4? How do you know? Can you say it in a way that would convince everybody? Like demonstrate it, show it, prove it?
Well, to get it twice, you'd have to get lucky twice.
Have to get lucky twice.
So one head is 50, and then to get lucky again, then you get 25.
1 heads to 50, to get lucky again, another 50%.
Yeah.
But 50% and 50% add up to be 100%.
But you'd have to get lucky twice. Well, I don't know.
There are 4 possibilities from the
4 possibilities.
2 chances you get hit.
What are the 4 possibilities?
Heads or tails, heads or tails.
Heads, tails, heads. Right, so there's heads or tails the first time, and heads or tails the second time. Right, so that seem like 4 possibilities? Like, how would you prove that, Johnny? I like the way you're thinking. I think you're thinking well. Can you spin that out a little bit further? So what do you mean 4 possibilities?
From the total outcome.
For the total outcome?
Yes.
How about I help you spin it, because you're right on the right track. What is the final thing that, what if I said, hey, I just did it, I flipped the coin twice. What happened, Mr. Aaron? Well, this happened. What possible different things might I say? Maybe that didn't help. How about if I do Johnny's way a little bit more and go, okay, yeah, the first time you flip, let's say first time you flip a coin, you're going to get heads or you're going to get tails, like Johnny's saying. And then the second time you flip, so say you got heads the first time. Then you're going to get either heads or tails on the second flip after getting heads the first time. Or if you got tails the first time, you're going to get heads or tail the second time after getting tails the first time. That's kind of what Johnny's saying. That make sense? Just trying to draw it out pictorially. He's right on the money. Does that make sense? So, in other words, in the end, you can get, what is this? Heads, 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 tail, tail, head, or tail, tail. Aren't those the 4 different things that can happen when you flip a coin twice? So what's the chance of getting 2 heads? 1 out of 4, like you all were saying, huh? It is right. It's 1 out of 4, isn't it? Make sense how they do probability kind of things? Just draw a little tree like that, a little action tree. And on this one, aren't they saying 3 flips? Yeah, 3 flips. So now, let's add another layer. Because they're saying up here, what if you flip the coin, 3 coins? Let's do another layer. Let's do a 3rd flip. So say you got heads the first flip, heads the second flip, then you could get heads or tails the 3rd flip. Or if you got heads then tail, you could follow with a head or a tail on the 3rd. Or if you got tail head, you could follow with a head or tail on the 3rd flip. Or if you got tail tail, you could follow with a head or a tail on the 3rd flip. Does that make sense? Now put it all together. This all leads to head, head, head. This leads to head, head, tail. This leads to head, tail, head. This leads to head, tail, tail. This leads to tail, head, head. This leads to tail, head, tail. This leads to tail, tail, head. And this leads to tail, tail, tail. Good to put that tree right on your 3x5 card for the next exam. Nice just to have it there. We don't have to map it out or anything. We'll use that kind of thing a lot. So there's all the different things that can happen when you flip a coin 3 times. How many different things are there? Notice how it splits in 2. It's like a cell splitting in 2, splitting in 2, splitting in 2, right? We had 2 options. They each split into 2. 4 options. They each split into 2. 8 options, right? 2 options, 1 flip, 4 options, then 8 options, etc. Right? So, what if I said, hey, what's the chance of getting 3 heads in a row when I flip a coin 3 times? 1 out of 8, huh? Chance of head, head, head. It's 1 out of 8 things that can happen, right? So that's how we do probabilities. We just map out what can happen. And we just say chance of 3 heads in a row is 1/8. Not very likely, is it? And it feels right, doesn't it? When you flip a coin, it's pretty lucky if you get 3 heads in a row. Yeah, Janelle.
I'm not quite understanding. So, like, you have the heads and tails, then the second part, like, is that the possibility you might get heads or tails?
Mm-hmm. Yeah, so this is the first flip. So the first flip, you're either going to get a head or you're going to get a tail. And if you get a head the first time, then the second flip could be head. Or the second flip could be tail after getting a head the first time.
And then the next one is, it could be
Head.
head, tail.
So if you went head, head, then you could get head the third. After getting head, head, you can get head the 3rd flip or tail. Or after getting head, tail, you can get head the 3rd flip or tail the 3rd flip, etc. Is that little tree making sense? Call that a probability tree.
At the end, for the fourth, for the final flip, it's head, tail, head. What is that? Like, I don't know.
So I'm just following the yellow brick road here. I'm just
so you're just going across the map that
just head, head, head. Oh, yep.
Okay.
I'm just listing the conclusion.
And you're doing this because it says flip 3 coins.
Right. So we're flipping 3 coins. Okay. So now what's their actual question? They say, I don't know, what do they say? Oh, right here. More tails than heads. More tails than heads. More H than T. Or more T than H. More tails. And so among these 8 results, these are the 8 different things that happen. How many of them, which of them, have more tails than they do heads?
And that's how you got the ones from the bottom, and that's how you got the answer, right?
Right.
Those ones had the most tails.
So this one has more tails than heads, doesn't it? And this one has 2 tails and only 1 head, so that's more tails than heads. This one has 2 tails and 1 head. And this one has all 3 tails, so that's certainly more tails than heads. So those 4 results, which is exactly what I've listed here, are the 4 different results that have more tails than they do heads.
Thank you.
So what's the chance if you flip a coin 3 times that you're going to get more tails than heads? What we just said, right? 4 out of 8. Do y'all see that? Because of the 8 things that can happen, 4 of them are more tails than heads, aren't they? So the chance of getting more tails than heads when you flip a coin 3 times is 4 out of 8. Which is still 50%. And that makes sense, because you're either going to get more tails or you're going to get more heads.
That's only the 2 variables then, right? The H and the T.
Right?
You always only have 50%.
No, they can ask all kinds of tricky questions. Like I could say, what's the chance of getting exactly 2 tails? What would that be? What if I said exactly 2 tails? How many of these 8 results have exactly 2 tails? Not 1, not 3, but exactly 2. This one, this one, this one. 3 out of 8 in that case. So it's not only 50-50, that was just a coincidence. Mm-hmm. Making sense? So there's all kinds of different questions they could ask us about this, right? That all good? That making sense? Probability. All right, let's move. Okay, so it says a sample space. What is a sample space? Everything that can happen, like what we just did here, right? This was the sample space. It just means a list of the different things that can happen. That's all it means. So they're saying here's the sample space, and they're just calling them O1, O2, O3, O4, O5. Outcomes 1, 2, 3, 4, 5. And they're saying the probability of outcome 1 is 0.26. And the probability of outcome 2 is 0.44. So here I can answer this question right now. This is 0.26, and the probability of outcome 2 is 0.44. You don't need those zeros in the front, right? They don't do anything. So we got those 2. Now, how am I going to find the other ones? Well, look what they say here. Find the probability when O3, O4, O5 all have the same. If O3, O4, and O5 are all the same, find them. How can I do that? Any ideas? If the chance of rain tomorrow is 70%, what's the chance it won't rain? 30%. How'd you come up with that? Do what?
It makes 100 to find
Yeah. Subtract from 100, huh? Right? So probabilities have to add up to 100%, don't they? Rain and no rain have to add up to 100%. So that means that the total of the probabilities, the total of all probabilities must equal 100%, or what's 100% in a decimal? 1.0 decimal, huh? That's the same thing. 1.0 decimal is the same as 100 percentage. Remember how the decimal moves back 2 places, you know? So 1.0 decimal is the same as 100 percentage. So, okay, so what? So, okay, we know the O1 is 0.26, O2 is 0.44. I don't know what these guys are, but they're saying they're all the same. So call them X if you want. Call them X. Why can I call them all the same letter? Because they're all the same amount, whatever they are. Notice I don't call them X, Y, Z. I call them X, X, X because they're all the same, they told me, whatever they are. So that means, do you see what equation I'm going to write now? You tracking with me? 0.26 plus 0.44, this one plus X plus X plus X must all add up to be 1.0 or 100 percentage, or I'll do decimals, 1.0 decimal. Right? Because that's like rain and no rain, huh? They have to make 100%. They're everything that can happen. That's what sample space means, everything that can happen. So we can solve that little equation for X, a little algebra time. All right. Add these up. What is that, 0.7? That's just 7 or 7.0, huh? And X and X and X, algebra? What is it? Oh, yeah, they're going to be, huh? You're already figuring out the problem. You're totally right. Yeah, I'll do it slower, but you're totally right. X and X and X must be 3X, because sometimes it's hard to guess ahead of time, but you're totally right. And then how do you solve this little equation for X? Remember algebra? You subtract the 0.70 from both sides, the 70 cents, And so 3x is $1. This is $1 minus 70 cents, 30 cents, right? Last step to get x alone? Divide by 3. I'm kind of running out of room here. I'm gonna. It won't let me. All right. 3x is 0.30. Divide by 3. X is 0.10. Yeah, so each of them is 0.10. Each of them has a 10% chance. So each of these is 0.10, 0.10, 0.10. If you add that up, that's 0.30. Add these two up, 0.70 makes 100%, or 1.0 decimal. That good? That makes sense? We got to do part B, huh? Find the probability assignments. Find the probability assignment for the probability space when now they're giving me 05 and they're saying, what are they doing? They're giving me 05 and they're saying 03 is the same as 04 and 05 combined. That's weird. I'm going to go to a fresh screen. If y'all got that copy down? We good there? All right, because I need some new stuff here. That was too quick. It'll be on YouTube. So, let's try part B. So now part B, they're changing the game. Remember, whatever comes above is still true for both parts A and B. So it's still the case that 01 is 0.26 and 02 is 0.44. That's still true. But now they're changing the story for 03, 04, 05. It's saying 05 is 0.11. Okay, so that's 0.11. And 03 is the same as 04 and 05 combined. 03 is the same as 04 and 05 combined. What do I do with that? Any thoughts? What can I do with that? 03 is the same as 04 and 05 combined. Well, can I start with 03? Do I know what that is? It says 03. You want 03? Okay. Go grab 04 and 05 and add them up. Well, I don't know what 04 is. Right. So you better start with 04. What's 04? Call him X. Because I don't know what 04 is, right? There's no way to know what 04 is. So just call him X. And now, what is 03? X plus 0.11. Because he's these two combined, isn't he? 03 is 04 and 05 combined, they said. Does that make sense? So we've got 01, 02. 03 is like two things, because it's two things combined. 04 is just X, and 05 is just the 0.11. And all those are going to add up to be 1.0, right? So 0.26 plus 0.44 plus X 0.11. So this is P01, 02, 03 plus X separately plus 0.11 separately. All adds up to be 1.0. Is that kind of weird how we have the X twice and the 0.11 twice? But that is right, huh? Because 04 is just X, 05 is just 0.11, and 03 is both those together. That's what they said, right?
Question.
Yeah, Janelle.
For the 05 equals 0.11 and 03, so is that saying 05 and 03 are 0.11? If you get what I mean? Or is 03 X?
So 03 is both these together.
Oh, okay.
Yeah, that's why I'm underlining it. So 03 is these together. 04 is just X, and 05 is just 0.11, but 03 is them together. Good, and then we solve that equation for X. So a little bit of algebra again here. So X and X make 2X. When do X and X make X squared? When you multiply. We're not multiplying them, we're adding them, huh? So it just makes 2X. And then you just use your calculator for those numbers. Whatever, 0.26, 0.44, that's 0.7 again, huh? 0.1 is, and 0.22, 0.92 is 1.0. I just added up all those numbers. How do you finish solving for X? Good, good. Remember some algebra steps here? Yes, subtract the 0.92. So that's like $1 minus 92 cents over there. So I'm going to bring it up here again. So 2X equals $1 minus 92 cents is 8 cents. Remember these algebra kind of steps? Get an X alone and then divide by 2. X is 4 cents. 0.04. So we got X. Okay, great, we got X. So can we actually answer the question now? Well, yeah. we've already got 01, we've already got 02, we've already got 05. So now x, everywhere we have x, the mystery's over. We now know what x is. It's 0.04. So right here, this x is 0.04. So that's that one. And this one is 0.04 plus 0.11, which means it's 15 cents, right? 11 cents and 4 cents, 15 cents. That's 03. And we got it. Good? Questions on that? Okay, I'm going to move on. That was 4 candidates are running for mayor of Happyville. According to the polls, candidate A has a 1 in 5. So that's how we got the 1 in 5 there. They're just telling me that one straight out. A's 1 in 5. Probably winning. Oh yeah, they even said it right there. Oops, it's kind of off the screen. Of the other 3 candidates, all we know is that candidate C is 3 times as likely to win as candidate B, and candidate D is 4 times as likely to win as candidate B. Oh, that's kind of weird. Okay, I've got all the answers there for you, but how did I come up with that? Well, how about we do this? A plus B plus C plus D. What must they all add up to be? 1.0 again, right? Or just 1 if you want. Again, because this is everything that can happen. So they always add up to 1.0 decimal, which is 100%. It's like rain and no rain. So now let's kind of take it slowly. It's saying candidate A is 1 in 5. So A is 1/5. Good so far. And then what does it say? Let me see. Candidate C is 3 times B. So candidate C is 3B. You good with that? Candidate C is 3B. So I'm taking those words. C is 3 times as likely as B. And D, and B will just stay B. We'll just leave B as B. We don't know what that is. Candidate C is 3B, 3 times as likely as B. So now all we need is D. What does it say about D? D is 4 times B. D is 4 times B. There's an equation. With only one. You want to get it down to just one letter, right? That's what's good. That's what's important, is to get it down to just one letter. It just has B, so we can solve that equation for B. See how I came up with that? I just followed what they said. C is 3 times B. D is 4 times B. 4 times B. Like that? Okay. Can we solve that equation? Fractions are a little bit of a pain. So let's add these up. This is 1B, 3B, 4B. What's that, 8B? 8B. 1.0, I'm just going to make that 1. Good to there. Now, how do I solve for B? What do you do with fractions?
Multiply the reciprocal? Or
You could, yeah, right. I'm trying to think what would be the best way. Yeah, probably, yeah. Well, is that right? Yeah, probably. Probably easiest for y'all just to multiply through by 5. And you got to do everything, huh? Whenever you multiply, you got to multiply all of them like that. And that'll cancel this and make it 1, right? The 5s will cancel, just be 1. Remember that kind of stuff from algebra. 5 times 8 is 40. 5 times 1 is 5. Is that step okay? Let's pause there for a minute. That's the harder step. Basically, when I have fractions, I always tell my algebra students, just multiply through and get rid of them, because fractions are a pain. So the 5s cancel, just 1. But you got to do the 5 with everybody, huh? So 5 times 8 made 40. 5 times 1 made 5. Remember all that kind of stuff. Now there's no more fractions. Much easier to deal with. Just get them out of there. So if you ever have fractions, just multiply by the denominator, everybody. That just gets rid of them. Okay, so what's our next step in trying to get B alone? Subtract that 1. And we get 40B is 4. Last step, divide, right? Divide by the 40. What is 4 divided by 40? Reduce the fraction, right? Divide top and bottom by 4. Reduce that fraction, 1/10. Good there? So that's how I got B is 1/10. Because that's B. That's what B equals, right? So B is 1/10. Now, how did I get C? Well, remember, C is 3 times B. So it's just 3 times 1/10, or 3/10. And D is 4 times. Yeah, what happened? So here, let me go a little slower. C is 3 times 1/10. Remember what happens from your algebra days? when you have a whole number like 3 multiplying a fraction, that 3 is really over 1 and goes to the top. Do you remember that? 3 over 1, that's why it becomes 3/10. The 3 goes to the top. Whole numbers are really over 1, they go to the top. So what happens with D? D, they told me right here, is 4 times B, so 4 times 1/10. Now that I know B is 1/10. And where does that 4 go? To the top, right? Because it's over 1. It's a whole number. So it's 4/10, and then you reduce that fraction. You always reduce fractions when you can. Divide by 2 top and bottom, 2/5. That's D. And there we go. A little tricky. You good with that? Questions I can answer? All right, I'll move on. Okay. A card is drawn at random out of a well-shuffled deck of 52 cards. Find the probability of each of the following events. Event 1, draw a jack, draw a club, draw 4, 5, 6, 7. Okay. If you've never played cards, it's going to be confusing. Let me draw a deck of cards. So, let me see, what's best? I'll just go down 2, 3, that's probably too big. Let's see here, let me do this. 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, not king, what am I doing? Jack, queen, king. Maybe I'll put the ace up here, I don't know. All right, and then across the top go the different suits. Do you know the suits? So hearts, diamonds, clubs, and spades. So, okay, and then, so here we go. So there's how many cards in the deck? 52. Okay, so this is the ace of hearts, ace of diamonds, ace of clubs, ace of spades. And this is the 2 of hearts, 2 of diamonds, 2 of clubs, 2 of spades, 3 of hearts, 3 of diamonds, 3 of clubs, 3 of spades. I'm going to write them all out here. 4 of hearts, 4 of diamonds, 4 of clubs, 4 of spades. 5 of hearts, 5 of diamonds, 5 of clubs, 5 of spades. 6 of hearts, 6 of diamonds, 6 of clubs, 6 of spades. 7 of hearts, 7 of diamonds, 7 of clubs, 7 of spades. 8 of hearts, 8 of diamonds, 8 of clubs, 8 of spades. 9 of hearts, 9 of diamonds, 9 of clubs, 9 of spades. 10 of hearts, 10 of diamonds, 10 of clubs, 10 of spades. Jack of hearts, jack of diamonds, jack of clubs, jack of spades. Queen of hearts, queen of diamonds, queen of clubs, queen of spades, and king of hearts, king of diamonds, king of clubs, and king of spades. There they are. 52 cards in all. The hearts and diamonds are red. All these ones are red. And all these ones here are black. So red and black. Okay, so that should take care of any questions they have for me. So what's their question? What's the probability of drawing a jack? So we're talking probability now, chance of something happening. So if you're playing cards and you're really hoping to draw a jack, you're drawing out of the deck, you're thinking, I just need a jack and I win this game. I just need a jack. What's the chance you're going to get a jack? What's the probability of getting a jack? That's what E1 is, right? E1 says jack. So they're really saying, what's probability of getting a jack? Do you know how to do probability? It's the number 4, whatever you want, over the total for probability, right? Like if we flipped a coin, what's the chance of getting heads? 1 out of 2. You all knew that because there's one thing you want, heads, out of 2 things total. So how many jacks are there? 4 jacks, right? So there's 4 jacks out of how many cards total? 52. 4 out of 52. We've got to reduce that fraction. But that's basically the answer, isn't it? So yeah, divide top and bottom by 4 with your calculator. It reduces to be 1/13. The chance of getting a jack is 1 out of 13. That's because there's 13 kinds, of course. You know what I mean? Ace is kind of like a 1. Ace through 10, 11, 12, 13 different kinds. Jack is one of the 13 kinds. So it makes sense. There's a 1 in 13 chance of getting a jack. Makes sense? B. What's the chance of drawing a club? Let's do that one. So this was A. Let's go up here for B. Probability of getting a club. What's the chance if you draw a card at random out of the deck, you're going to get a club?
13 out of 52.
Yeah, how many clubs are there? Well, these are all clubs right here. There's 13 clubs out of 52 cards. The total always goes in the bottom, huh? 13 clubs out of 52 total. And then you got to reduce that fraction with your calculator. Divide by 13 top and bottom, 1/4. And that makes sense because 1 out of 4, there's 4 different suits, they call them. Clubs, hearts, diamonds, and spades. So clubs is just one of the 4 suits. 1 out of 4. Final question, C. Draw a 4, 5, 6, or 7. What's the probability of drawing a 4, 5, 6, or 7? Kind of running out of room. I'm going to erase this here. So what do you think? 4, 5, 6, or 7? So 4, 5, 6, 7 is all these cards, huh? What's that? 4 times 4, 16 cards? Isn't it 16? 16 cards out of 52 total. Reduce that fraction. Divide by, I don't know, 4. That would be 4/13. 4/13 is the chance of getting a 4, 5, 6, or 7. Good? Questions on that? All right, I'm going to move. And let me give you the definition. So, probability is 4 over total. As you know, we were just doing probability. Odds is very similar. It's just slightly different. Instead of 4 total, it's 4, and they usually do it sideways. Instead of total, it's against. And they usually do it sideways. They put a colon. You can put a colon, or sometimes they write the word 2 in the middle. Whatever. I don't care on the form. It doesn't matter. Could be any of those ways. So that's the difference between probability and odds. So probability. So notice they both start with 4, don't they? They both start with 4. They only finish differently. Probability finishes with total. Odds finishes with the number against. All right, let's see what we're talking about. So part A, an event E with probability 4/9. So they're saying on part A that the probability of something is 4 out of 9. Turn that into odds. Change that into odds. How do we do that? So odds is just like probability, slightly different. Instead of 4 and total, it's 4 and against. So, okay, what are the odds? Remember, look, they start the same, don't they? The beginning of probability and odds starts the same. They both start with 4. So this is the amount 4, and this is the amount total, because that's a probability fraction, right? So 4 is the number 4. 9 is the total. So imagine, you know what helps me to think about it? It's kind of like a debate or something, an argument in a room, a debate over a topic. And 4 people are for the issue, and there's 9 people total in the room. Make sense? 4 people are for the issue, 9 people total in the room. That's what probability is, 4 over total. Odds starts the same, so the first number is going to be 4. They start the same. 2, T-O. Now, what's the other? This is the number 4. It finishes with the number that are against. So if there's 4 people for some issue and there's 9 total in the room, how many are against the issue? Must be 5, huh? And that's the answer. 4 to 5. So odds is 4 and against instead of 4 in total. That's the only difference. They're very, very similar. So that makes sense. Probability is 4 total. Odds is 4 against. So can you do part B? Try part B. Part B says probability of something is 0.2. You know what you need to do is turn that into a fraction. Make that thing a fraction, 0.2. How do you make 0.2 into a fraction? That's 2/10, huh? You with that? It's in this decimal is in the tenths place. It's 2/10. And can we reduce that fraction? One-fifth. So the probability is 1/5. Now turn that into odds. So take that one. So we changed the decimal into a fraction to make it easier for us to change it into odds. Now change that fraction into odds. All right, Jill got it? What is it? 1 to 4, very good. Because this is number 4, this is not against total. Remember, probability is always 4 over total. 4 over total. Odds starts the same. They both start the same. They only finish differently, huh? So it's going to be 1. They're going to start the same. The only difference is odds is like a debate. You know, people for and against the issue instead of for and total. So if there's 1 person for the issue, 5 total, there must be 4 against. 1 to 4. Good? So you might want to put an example of odds probability changing on your 3x5 card for the exam 2 weeks from today. Maybe the last math exam in your lifetime. Maybe for some of you. If this is the last math class for your college career. Yeah.
And so you have to make it add to that number in the bottom?
Right, because that's the total. Yeah. Make sense? Yeah. Exactly right. Good. Okay, so what is the problem? Okay, the odds in favor of Chris winning are 9 to 8. What's the probability that Chris will win the election? Let me give you a second, rather than me just whipping it out. I think you'll get more out of it. So now we're changing the opposite way, from odds back into probability. We just did probability odds, now it's back. Give that a try. See if it's making sense for you. Think about the definition. Odds is for and against, probability is for and total. So they're saying odds are 9 to 8. Odds are 9 to 8. And odds are for and against. Right? Odds are for and against. And now they want probability. Remember, that's 4 over total. They both start the same. The four. So they always start the same, don't they? No difference in the start. The only difference is in the end. The end for probability is the total. So I have to total these. 9 plus 8, which makes 17. There we go. Very good. Is that making sense for you? So that's part A. And then part B, what's the probability that Chris does not win? So this is the probability that he wins, right? The 9/17, that's the probability he's going to win the election. Wins. So what's the probability he does not win?
8 over 17.
Yeah. And how do you come up with that?
Because it's the against, so it would be like...
Oh, yeah, you can do it that way. You can just go right from the against. Nice, I like that too. Yeah, in general, like if I said, hey, the chance of rain is 70%, you would know that the chance that it's not going to rain is 30, and you get that by taking 100 minus 70, right? 100% minus 70, you'd get 30%. So generally, you subtract from 100%, don't you? When you want to do the not of something, if the chance of whatever is 70%, then the chance of not that is 100 minus that. Or in decimals, instead of 100%, we could call this 0.7, and this would be 1 minus 0.7, 0.3. Same thing, right? 100% is the same as 1 decimal. So the probability does not win is going to be 1 minus 9/17, which will come out 8/17. I'll work it out. Is that making sense, though? Whenever you do the not, it's 1 minus. It's 100% minus. So then, 1 is 17/17 to get a common denominator there. Subtract them, and you get, sure enough, 8/17. It's a chance that Chris will not win. See how these two add up to be 1, don't they? Because he's either going to win or not win. What happened? Did Chris win? No. Did he not win? No. That can't happen. He's either winning or not winning. They have to add up to be 17 over 17, 1. Okay. Rain or not rain? Is that good? All right.